Okay, so we were actually recapitulating the things which we have already learned, just to uh, point out the important points once again, so that beginners do not have uh, much problem in future uh, proceedings. Okay, so today I'm going to start with this symbolic constants. Okay, so in many programming language you might be using several universal constants, which for which the values should be remain same uh, throughout the program. Okay, the most common such uh, uh, constant is like pi. Uh, when you will be actually writing program to compute, huh? Is there any problem?
Start the recording.
Actually, what happens? Joydeep sir is not there. I couldn't get in touch with him. Unless he joins, it will be very difficult. It is not possible for me to start the recording or you. Okay, let Joydeep sir join. Hopefully, he will be joining and he will start the recording. Fine. Anyway, so see these things. You don't need to have much recording. You will get this document. Okay. If even if the recording is not available, you will be able to understand this thing without the recording, since you are attending the class. Okay. Anyway, what I was trying to say that this type of constant, like when you are writing a program of computing area perimeter of several geometrical structures, then often we use pi. As in most of the formula will be having pi as a uh, constant. Now instead of writing the value of pi at the each and every places where we are computing the area perimeter of different geometrical um, structure, we can just define pi to be a constant and use that value everywhere without explicitly writing the value in several places of the program. So one way, obviously, you can declare like float pi equal to 3.14 at the beginning, or just at the beginning of your main block. But remember, this pi is now is being defined as a variable. Obviously, you are initializing this with a constant value and you are not going to change it anywhere. That is one way. But there is another way where we can define such universal or unique constant is by using macro. Just like we have used has include. Okay. C allows us to define several macros on the above of the main function. Okay, so we'll discuss the macro in detail afterwards, but right now we can just use that macro definition to define our constant in a different way. That we can write has define place, I mean there will be a blank space, then pi 3.14. See, just on top of main, we'll write like this, no semicolon. So what it will, I mean, C compiler has a component called preprocessor. So when we write this type of program, before it goes for actual compilation, preprocessor extend that program. So what it does, it just replaces every occurrence of this text pi with this text 3.14. So inside the program, wherever I have written pi, before feeding it to the actual compiler, this pi will be replaced by 3.1. Okay, so this is one way of defining universal constant in your program using macro. Okay, let me show one example program so that you can understand how we can use it. Okay, this is the formula. As you can see, this is uh, has defined the symbolic constant name and space value. There is no semicolon. Okay, this is an example. Has defined pi 3.1. Okay, so let us see that example. Then it will be easy for you to understand. Uh, Let me open this area of circle program. You see, this is the definition, macro definition for pi. So now what will happen? Everywhere I have used this pi, as if this program will not see this pi. The compiler will not see this pi. It will see this float within bracket 22 by 7. So before feeding it. So this is equivalent in writing this thing followed by radius star radius. Understood? So we can have a program where we can compute area of circle, perimeter of circle, area of rectangle, area wherever this pi is needed. Okay, it will be uh, that instead of writing the value everywhere, writing this thing float within bracket 22 by 7 everywhere, we can just write this statement and use this pi everywhere. Okay, so this is the application of this macro statement, which is called symbolic constant. We are as if we are defining this constant symbolically using this macro definition. Understood? Next, uh, operator precedence and associativity. This has been discussed in a great detail, but still, since this is very important, I am recapitulating it again. Okay, so as we are familiar with this precedence while computing any expression, arithmetic expression, uh, the famous rule of BODMAS or we apply. Okay, when because a typical expression involves multiple operators. Okay, plus, minus, division, multiplication, remainder, several assignment, several uh, operators are there. Now, how do I actually uh, find out the order of evaluation of different operators? Because I cannot simultaneously perform all the operations indicated by several operators. I have to go one by one. So, in mathematics, we have rule, specific rule that which one should be done first, then which one. Otherwise, what will happen for the same expression, if we apply arbitrary order of evaluation, then I might get one result, you might get another result. So that is not uh, expected. There should be a conflict free, unique order of evaluation we need to follow. So C follows similar syntax or rules when in an expression several operators are present, then what will be the order of evaluation? All of us must know that, otherwise we may not be properly write program or may not be able to properly interpret the result. Okay, so what C does, C actually uh, divides all the possible operators in several precedence levels. Actually there are 15 precedence levels. Okay, now in each level, one or more operators are placed, and the labels actually dictates the priority or precedence of different operators. Like when different operators are present in the same expression, then if uh, it belongs to any operator belonging to this precedence level 1 must be executed first, then precedence level 2. So whose precedence level is less, that has higher priority. Understood? Now, since the precedence levels contains multiple operators, now what would happen when there are more than one operator from the same precedence level? Then which one should be executed first? What will be the order of evaluation? So that is actually dictated by this associativity rule. So every precedence level is associated with a associate. I mean, is uh, attached with a associativity, like either left to right, or for some it is right to left. Understood? So if suppose this plus and minus, okay, where it is this plus minus, the precedence level 12. Now if an expression contains both plus and minus, okay, now since plus appears in that expression, the left, that will be executed first, then the minus. If an expression minus appears before plus, then that minus will be executed first, then that plus. Okay, so this is the concept of associativity. Understood? So together, precedence and associativity together dictates the actual order of evaluation of various operators in an expression. Understood? Is it okay? Let me take an example. Like
Sir,
this particular expression. This is an example expression. There are several operators, like this is one operator, this is another, this is another, this is another, this is another. So total 5 operators are there. Okay. Now in which order they should be evaluated, so that expression can be evaluated without any conflict. So it is quite similar to the Bodmer's rule, but here we have to apply the precedence and associativity together to find out the order of evaluation. Am I audible, students?
yes, sir. Sir, there is a doubt
Yes,
in
sir.
previous
Yes,
slide.
sir.
Okay.
Yes, sir, you're audible.
I
Okay.
have doubt in previous slide.
Previous slide.
Yes, sir.
So if, please say a little bit louder. I can't hear you. Previous slide.
Yes, sir. There is a doubt. Sir, please
Yes.
back the
This
page.
slide.
Yes, sir.
Yes. Tell me what is the doubt?
Sir, on the 14th level, there
Hmm.
is a plus minus, and in associativity, that is mentioned there right to left.
Hmm.
And on 20th level, there is a plus minus, which is mentioned that left to right.
Okay, these plus minus and these plus minus are separate. This is called unary plus minus. This plus minus is, suppose you want to write minus 23. This is the value, this is the negative of 23. This is the unary thing. And this plus is addition. That means when we apply 2 plus 3. So 2 minus 3. So this minus and this minus are not same.
Okay, sir. Okay, sir.
Understood?
Okay,
See,
okay,
this
sir.
is
I
written
understood.
unary plus minus. This is binary addition subtraction.
Okay, sir. I understood.
Okay. So now let us go to that example. So we have, in this particular example, we have 5 operators. Now we have to fix the order. Otherwise, if you choose arbitrary order, then I may get one result, final result, that will be put inside X. You may get another value, which is not allowed. We should have a unique order of evaluation. So let's see, this division and multiplication, they belong to the highest possible level. Here division, multiplication, they belong to level 13. Okay, then plus and minus, they belong to 12. And finally the assignment operator, this one belongs to here level 2. So it is quite clear that out of 3 different classes of this operator, we can see these 2 is having highest precedence, highest precedence among these 5 operators. Now these 2 are having second highest precedence, and this is having the least precedence. Okay, now our problem is still not solved, because out of these 2 I cannot perform 2 simultaneously. I have to fix, I mean, not only I, the computer needs to perform one by one, because computer's processing unit, it can perform only one operation at a time. Although it can do it very fast, but at any particular moment it can only perform one operation. So I have to fix the order, that among these 2, which one should be targeted first. So out of these 5 operator, I have to rank 1, 2, 3, 4, 5. Okay. So among these two operators belonging to the highest precedence level, now I have to refer to that table to check what is the associativity. It is saying left to right. That means whoever is appearing left on the expression will have the higher priority than the other one. Okay, so obviously it is quite clear that the division is appearing lefter than this multiplication. So it will have the rank 1, this will have rank 2. Fine. Then the next group is plus and minus. Again, go back to that table. Plus and minus, addition and subtraction, it is also having left to right associativity. So since plus is appearing left, then this minus, so this will be evaluated third, this rank, and this will be evaluated fourth. And finally, this assignment operator, since it is having the least precedence among all the 5 operators, so it will have a rank 5. Okay, so it is quite natural. This will be the thing. Based on precedence level, this grouping will be done, and then based on priority associativity, after applying associativity, we will get this order of evaluation, which is unique. It is not arbitrary. It is fixed for any C programming. You need to follow this rule that if such thing appears that multiple operators of different precedence level are there, then you have to fix the rank, and accordingly it will be performed. So this expression will be evaluated by executing this operator first, then this operator, then this operator, then this operator, and then this operator. Okay, let's see what will be the result in this way. So first this will appear like 200 divided by 10, so 20. Then next operation, this one, 3 into 10, 30. Then this one, 100 plus 20, 120. Then this one, 120 minus 30, 90. And finally this 90 will be assigned to the value x. So finally, after execution of this entire statement or expression, x will get the value 90. Okay. Now you can always use parenthesis to explicitly dictate your order of evaluation. Like if you don't want to remember so many things, you can use as many parentheses, opening parenthesis and closing parenthesis, to dictate your desired precedence level. Or sometimes it is not optional, it is required. Like you want to override the default precedence, like you want that, okay, in your expression you want that uh, this, instead of this plus, this minus should be done first, then you have to enclose this within a parenthesis. Okay, in this way, if you desire something different than the default order of evaluation, then you have to use parenthesis. Okay, or in some time, even if it is not needed, you can use pair of parentheses just to dictate your default order of evaluation also, since if you don't want to remember all these uh, bodmas type of rules. Okay, but if you when you will actually start uh, writing more and more program, you will get familiar with this precedence level automatically, and then you will find that it will be you will be encouraged automatically to write parenthesis free expression. Okay, but initially you should try to use parenthesis as much as possible to avoid any confusion. Understood? This is just a recommendation. Fine. Just a minute. মা, Now next thing is that data type conversion. Since we are dealing with data in most of the programming, what we are doing some computation, and computation involves data. We are executing several expression, simple expression like assignment, huh, like this x equal to v some variable, huh, and we have seen each variable has an associated data type in C, and that has to be defined at the beginning. Now when some expression deals with several different types of variable, like some expression, like here if both of them are integer, that's fine. But suppose x was defined as float and v was defined as say int, okay, then what will happen? Or we have a long expression like v plus say y minus z, several variable, and it may be float, it may be defined as double, okay, this type of situation may appear. Then how this data type should be converted from one to one, okay, how this should be converted, because ultimately this assignment is there, so x must have some value which is already defined as float. Now x should get a float value, a real number, but here it may appear on the right hand side, you might have different variables of different data types. So the conversion of one from one data type to another data type is very much necessary, and C has some implicit rule that how, when required, how this type of conversion will take place from one data type to another data type. Okay, let us take one example, then you will understand that when our expression involves data from different data types, then how does this conversion takes place implicitly? Implicit means by default C has some rules, and you need to understand that rule, otherwise you won't be able to understand how this conversion is taking place. There is a way you can override this implicit conversion by explicitly dictating the type of conversion you want. That is called explicit conversion. We'll see both of them. First let us see what is the implicit type of conversion that is followed by C compilers. Okay, let us see this uh, example, so that uh, okay, see here I have defined many types of variable, and also some of them are initialized with the some values. Okay, see these two ch1 ch2 are character variable where ch2 is assigned these are the integer variable, some of them are assigned some value like this. Okay, now what I am doing, I am playing with this thing to understand what happens when one data type gets implicitly converted to another data type. Like if you see this one, n1 equal to ch2, what I am doing, on the right hand side I have one character data type, and on the left hand side I have one integer data type. Okay, so basically here I am trying to put smaller thing into a bigger container. Understood? That means bigger container means n1 is integer, the size of the integer is 4 bytes,
32.
32 bit, whereas size of character is only 1 byte. Let's see what happens. As we have seen, this is a special type of assignment. We have already seen that character and integer can be assigned interchangeably because character is actually stored as an integer ASCII value. Okay, so when this will be done, the ASCII value will be printed, ASCII value of whatever the content of ch2, That means since ch2y was initialized with y, so ASCII value of y will be printed here. Okay. Now here what I am doing, I am trying to put the value or content of this integer variable into a float variable, and then trying to print that float variable. Then what will happen? See, this will be printed as a real number, and since the value was there only 97, it was integer, so remaining 6 places will be padded with 0, because nothing is there, it will be just extended by padding zeros. So this will be the expected output for this statement. Similarly, when I am trying to now putting a double, d1 is a double variable, and there I am trying to put the content of a float variable. Both are real number, but size of d1 is higher than size of f2. Now f2, what is the value of f2? 4.27. Now what will happen? It will do the same thing, 4.27 followed by some 0 padded over. Okay. Now let us try to put bigger thing into smaller container. That's the opposite thing. Now what I am doing? I am putting the content of d2 inside f1. That means this is a double variable which has larger size than the f1. Now what is the value of d2? d2 I have initialized with 29.397. Okay. Now if we try to print f1 now, you'll see this padding is now not 0. It is padding 999. Okay. You should try to see also. You can run this program when I upload this in the Moodle, and you can also try to add some more such experiment, and then see how they behave actually. Okay. Similarly, when I am trying to put the content of this floating point variable f2, which is containing, what is the value of f2? 4.27. Okay, this 4.27 inside this n1, and then trying to put this n1, then what will happen? It will just truncate, because integer cannot uh, keep anything beyond the decimal point. So this 4.27 will be truncated to 4, and output will be printed as 4 only. Understood? So these are the implicit or default data type conversion that is there in the
Sir,
C.
excuse me.
Yes.
Sir, why did F1 store 3.397.97 999 after that?
So
Can you
why
please
it is not,
re-explain?
see, it is not why. I mean, see, some when you are having larger space, huh, you are trying to put a value which was stored in a smaller place, and now you are extending. Now in an extension, we can pad the remaining portion, we can pad with 0 or something, but in C compiler it is the behavior of the C that for when it is extended from lower to higher, it will just bring all ones there actually. So the remaining padding in binary mode, when it is padded by all 1, then 9 comes. When it is padded by 0, it 0 comes. So this is just the compiler's own way to handle this type of conversion. That's why I am trying to show this one. It is just, I mean, you could have thought that what would have been the problem if it was padded by 0? No problem. But it is the C compiler. This is how it behaves. You should
Okay.
understand.
Thank you, sir.
Okay.
Yes, sir.
Now, as I have mentioned, that there must be some understanding that how when an expression that not only includes several different types of operators, but several different types of operands. Like types of operand means operands involving different data types. Now how they will be evaluated, because during evaluation they need to be converted automatically following this implicit rule. Because when we have this type of expression, ultimately some value needs to be computed which should be assigned to this x. Now, as I have mentioned, it is not only different types of operator, it is different types of data type that is being involved in this operator. So this implicit conversion must take place while evaluating this expression, and C compiler does that. And as I have already shown you that what should be how this, when this thing will be converted, I mean when we have a sub expression which involves, suppose this h and I are not same data type. Okay, suppose this h is long int and I is int. Now what would happen? How this sub expression will get evaluated? Whether it will be evaluated as int or whether it will be evaluated as long int. Okay. Similarly, what will be the fate of this sub expression? What will be the fate of this sub expression? So how, while evaluating this entire expression step by step, how the different data types will get converted implicitly. Let us show this example. Okay, suppose this is our example expression where we have different data types, like I is defined as int, this h is defined as long int, this f is defined as float, and d is defined as double. Now when this expression will get evaluated, the implicit data type conversion will take place like this. Okay, since this is the first operator, based on this precedence and associativity rule, this operation will take place first, the order of evaluation, this is the highest order. Okay, now what will happen? This I will be converted to a long just by possibly padding some zero. Okay, and then this result of this sub expression will be available as a long int, not normal int. Okay, then next, this expression where this multiplication actually involves two data types, one is float, another is int. Now this will be converted to float by padding 0.000, and the result of this sub expression will be available as a float. Now the third operator is this one, which has one long operand, another float operand. Okay, so when this operation will be executed internally, this sub result of this sub expression which was available as a long will again be converted to float, and finally this result of this sub expression will be available as a float. Then this fourth operator, which involves a float data type with a double data type. Now this float will be implicitly converted to double, and the result of this sub expression or the entire right hand side will be available as a double. And finally, since this is the last uh, operator which needs to be operated, that is assignment. Now since in the left hand side x is defined as an int, it will be converted implicitly, this double will be implicitly converted to int, and final result will be available as a integer, possibly by truncating some part, the decimal part. Okay, so this is one example of how the data type conversion takes place when needed implicitly, following the default rule of C programming, that you need to understand. Is it okay?
Yes, sir.
Yes, sir.
Okay, so now coming to this explicit type conversion, I think you have seen some example. Joydeep sir has already uh, shown some illustrative example where we have used this explicit type of first we have to understand when do we need explicit typecast. I mean this typecast, like when suppose I mean i am i am I am using one expression like x equal to a by b. Now suppose this is defined as float, but these two are defined as int. Understood? Now, suppose A's value is, say, some 13 and B's value is, say, 25. Then what you should expect in X? What result you should expect?
0.
So, and now you are saying, but naturally, I mean, usual, based on our usual practice, if you forget about this rule of C, you should want to get some, or like, suppose I multiply it by 100, then you should get something, some number, non-zero number. But
Yes,
as
sir.
someone was pointing out, if you write like this, if you just say int a equal to 13, int b equal to 25, and float x, and then you just compute x equal to a by b into 100, and then try to print x, you will get 0 to be printed, which is not
Which is
expected.
not expected.
Understood?
Understood.
So this is come out our exam.
But
But
since this automatically implicit type conversion will take place, this will be, the 0 will come. But since we actually don't want that, then we have to explicitly typecast, because this division, since without explicitly typecasting, this division operation is now taking place by taking two operand integer operands. So it will be performed as integer division. So there will be no decimal point will be considered. So it will be appear that 0 will come as the result. But we want that fraction. So we have to explicitly typecast any one of these operand to be float, explicitly typecast. Instead of eh, declaring here, we can typecast one of them for this particular operation only, to be upgraded to float value. So instead of 13, now it will be considered 13.0. And then this division operation will take place as a floating point division, and we will get exact results. Let me show you this example program, then you will be understanding. Suppose we want to write a program for which we will take, we will just take whatever you are getting the number in some continuous assessment. Suppose in continuous assessment 1, out of 15 what you have got, that value I will take as an input, and then I will just compute and print the percentage. That means out of 100 what is your obtained marks. So we have to compute this type of expression. Then what happens? How do I use explicit typecast to get the correct result instead of getting a 0? Okay, because always your number will be less than equal to 15. Okay, so unless you get 15, all of them will print without explicit typecast. All other number, marks obtained number, will print that as if you have got 0%, which is not desirable. Okay, so let me show you this one. See, int marks obtained equal to 13, in total marks equal to 25. Suppose I am computing here the percentage of marks obtained by a student in continuous assessment 2, for which total marks is 25, and float percent marks. Now if I write this without any explicit typecast, what I will get? See, what I have written, percent marks equal to marks obtained by total marks into 100. This is our usual practice in paper and pencil. So far we have used this formula only. Okay, but if I run it, I am getting a, the percentage of marks obtained is 0, which is not correct answer. So for getting correct answer, I have to write like this. The second statement you follow. I am explicitly typecasting this with float. Okay, this marks obtained. I am explicitly typecasting it for this particular. I am not changing the data type of marks obtained to float. The marks obtained, this variable data type will remain integer. But for this particular operation, I am uplifting its data type to be converted as float or real number. And then if I perform this operation, I will get the correct result. So if I now compile, file, save, and then compile and run, I am getting this 52%, which is correct. There are different ways of typecasting. I mean, instead of explicitly typecasting, I could have typecasting these marks obtained. I can typecast this total marks also. Like here, Control X, this one, like this. This is also allowed. Marks obtained, 5 float total marks. So this probably, yes, let us see. Uh, File, save, execute. Okay. So any one variable we can explicitly typecast to make this division a real number division instead of an integer division. Then we'll get that one. Okay. Understood.
Yes.
So this, in several occasions you might be finding it necessary to explicitly typecast to override the implicit type conversion and get the desired result. That is my point. Okay. Now, last thing, I would like to complete this discussion of recapitulation by highlighting some of the errors, because whoever is now uh, writing some program and saving and trying to compile and executing, they are facing several types of errors. Most importantly, they are facing syntax error or compilation error. So when you try to compile, it gives several errors. Now, what are the reason for that errors and how to tackle them? And apart from these errors, there are several other errors which you will get in future also when you write actually big programs. Okay, they are called runtimes error or execution error. That means you have compiled it and is found that your program is having no error, no compilation error. But when you are trying to run that program, it is crashing. It is not showing the result, it is crashing. The program is not getting executed properly. Then this type of errors are called runtime errors or execution error. So after successful compilation, it is not able to run properly. And third type of errors, that even if it is compiled successfully, ran successfully without crashing, it is giving you wrong result. That means the expected result you are not getting. You are getting something wrong, incorrect results. So programmatically it is executing properly, but the result you are getting which is wrong. So these three types of error mostly covers all possible types of error which you will encounter in writing and executing C programs or any other programs also using any programming language. So syntax error or compilation errors are basically the most important one for the beginner, is that they caught by compilers. Because they compilers looks for the stringent syntax rule or vocabulary, that if you just uh, forget to follow proper vocabulary of C programming, then C compiler will generate error. Like if you forgotten some semicolon after any statement, okay, or if you just don't follow the naming convention, like you are declaring a variable like 1 2 var, huh? which is illegal, this type of thing. So all the vocabulary related issues will be caught by compilers and they will be given as compilation error. There's several error message will come. So whenever you are getting such errors, you have to edit your code to make it free from any such error before going for execution, because eh, unless your program is compiled successfully, it will never run. It will never run. Okay, but how do you tackle compilation error? So you have to understand the meaning of these messages you used to get, like uh, in the bottom panel of say, like when we the simple program, let me, so if I just forgot to give the semicolon, and then I try to compile, then it will say that radius undeclared. See this, it is not saying that semicolon is missing directly, but I have to understand from this message that I have missed. That is the main point you have to look in. That it will never say that semicolon has been missed. It is saying radius undeclared because it is catching it here. I am using radius here, and since I have not been able to define radius variable using proper vocabulary, it is generating an error. So the although it is pointing as if the error is here, but actual error has happened here. That type of thing you have to learn from your experience while coding and getting this type of encountering this type of compilation error. And sometimes what happens, like you are getting several error messages. That means it is showing that you have multiple errors, but it may not be the actual thing. The compiler actually gives feedback as wherever it is finding the effect of error being propagated. Like you have done one mistake, but it may show as if it is getting five mistakes, five errors. Okay, so when you are writing a large program and you are getting after first compilation, when you are getting multiple errors, don't try to tackle all of them simultaneous. You just consider one error first and then save and recompile. Understood my point? You might be tempted that okay, I have got five error messages, so I need to find five different errors, and I will just try to find all possible errors, and I will I'll just eliminate all the errors, then I will be able to successfully compile it. But this approach is very wrong, because what may happen that these five error messages may not due to the five different errors. For a single error, since the consequences of that error may propagate at different places, your compiler may generate such messages. So try to tackle one error at a time. This is very useful recommendation. Okay, so you may be astonished sometime that just removing one error and saving it and recompiling, all the error messages has gone. Okay, or the other things is also possible, like when you just remove one error, okay, and saved it, recompile it, and you are now getting more errors messages. That is also possible. So it is always good, or it is recommended that you tackle errors one by one. Compilation error or syntax error, whatever you are getting, you tackle one by one. Just remove one error, save it, recompile it, and check again for the error messages. Again from there you tackle one error, remove that, and then in this way you proceed unless and until your program becomes completely syntax error free or compilation error free. Then you try to run. Understood?
Yes, sir.
Yes.
Yes, sir.
Okay. Now this runtime or execution errors, you may not get this type of errors right now, but in future when you actually try to write uh, larger program with more features of errors, like which we'll learn, like this type of error usually happens, most frequently happens for memory mismanagement. So when you are dealing with these simple variables, it may not appear, but in future when you actually try to use larger data structure like arrays or some other thing which we learn later, then you may find this type of segmentation fault is coming, especially those who are using Unix platform for executing program. They often get this segmentation fault. They used to come from this memory mismanagement, which you will encounter later. Okay, but right now you may encounter this type of division by zero, illegal operation. Like suppose in your program you have a statement like this. Okay, x equal to a by b, where the x is defined as float, a is float, data type is okay. Okay, but suppose the value of b you are getting it from user, like using scanf you are say sorry, you are getting this value. Now suppose during runtime, as an user I have given it as 0, then what will happen inside your program, which was successfully compiled, but in that run the value of b is 0, so it will try to execute a division by 0, which is totally illegal, so that time it will crash. So this type of error may occur in runtime. Your program is uh, totally compilation error free, because you don't know what the value user will give. Based on that, compilation is never done. Compilation is done just to check whether you have followed all the syntax or grammatical rule. Okay, so this type of thing you should remember, that in runtime you may get this type of error. And finally, the logical error, which will be very important and difficult to handle. Logical error means that your program is totally error free based on the syntax rule, and even in you have managed memory properly, so there is no runtime error, it is not crashing. But at the end the result is coming, like suppose you are trying to find out average of 10 numbers, and you have given some numbers, you know what should be the expected average, say expected average should be 3.84, but you are getting a result like minus 4.37. That means your program ran successfully, but the result you are getting is incorrect. This is very common. Now what is the reason behind it? Because it is called logical error, because the way you have solved the problem, you have used some algorithm, some solution recipe based on your understanding, and there is the error. It is not the, I mean, from programming sense, the syntax sense, vocabulary sense, grammatical sense, there is no error. And from runtime environment, using runtime environment, memory management, it is okay. But the algorithm you have used itself, it is having erroneous algorithm, which in paper and pencil may also generate wrong result. Okay, sometimes you solve the problem. If you follow the incorrect approach, you will get wrong result. So this type of error is very difficult to catch, because nobody will help you. Compiler will not help you to uh, catch this type of error. It is up to you, that you have to check whether you have done something wrong in terms of algorithm. Okay, but there are sophisticated compiler which comes with some debuggers. Okay, which will not recommend right now. The especially the students who will actually uh, be very much comfortable in programming after getting sufficient proficiency in programming, they should take help of the debuggers, like in Unix environment, there's a famous debugger called GDB, which you have to obviously learn how to use that so that you can get some help to understand or find out the logical error. But typically, for the time being, you have to actually use this type of crude techniques to identify logical errors. That means you have to, when you are writing a moderate or big program, you have to isolate error by commenting a block of statement to identify in which block there may be some logical errors. Okay. Then setting breakpoints like forcing execution or halt at some specific point to check the intermediate result, because ultimately you are printing the final result. But just like we check na in paper and pencil, we check step by step. So you have to use some dummy printf scanf statement to stop the execution after certain time and check what is the value of at that moment to find out whether up to that step your algorithm works fine or not. Okay, this thing you will learn by your experience. Actually, nobody will be able to uh, teach you. Everyone use different crude techniques to isolate and find out the logical errors. So it is through experience you have to learn. There will be obviously some guidelines, vague guidelines like this, but from your experience you will be able to learn them. Understood? But after getting sufficient proficiency, when you deal with very large program, then you have to use this type of debuggers. Okay, so that's all for today. From next class, I will move into the detailed discussion of decision making and branching, like the various kinds of if else statement, how to use them, especially what are the different variants available. Although Joydeep sir has actually shown you some of the example, primitive example of if else already, but we'll be discussing in great detail next class onwards. Okay.